Hi, this is Mrs. Vrobel. This is Chapter 10, The Mole, Part 4, and I'm back again with Mr. Mole. And today we're going to look at what is a hydrate and how does the number of waters relate to the name. And then lastly, we're going to look at the formula of a hydrate from laboratory data. Okay, so what is a hydrate? So a hydrate is a compound that actually has a certain number of waters attached to it, and these waters are bound to the atoms in the compound. The number of water molecules will always follow a dot that is written after the compound. So for instance, at the bottom of the screen there, it says sodium carbonate decahydrate. So that dot will represent the number of waters that are associated with sodium carbonate. And notice that deca means 10. So here is a chart that is in your book, and yes, you will have to know these prefixes. Mono and di and tri should be pretty easy, but some students have trouble with tetra, which is 4, penta is 5, hexa is 6, hepta 7, octa is 8, nona would be 9, and then deca is 10. Okay, so you'll do a lab where you heat up a compound and you might notice a color change as a result of the loss of water. And when you have the loss of water, we call this anhydrous. So in the lab, you will be calculating the mass of an anhydrous compound. And by looking at the differences between the hydrate and the anhydrous compound, you'll see how many waters are attached to that compound. So the procedure with doing a calculation for amount of hydrate, you start off with a known amount of hydrate, you heat the substance, and then once all the water has been removed or dried, you will weigh out the anhydrous compound. That mass that you see, the difference between the hydrate and the anhydrous, that is the amount of water that was attached to the compound. And you just have to convert that from mass to moles of water. And that will give you the coefficient of the hydrate. So for instance, we have an 11.75 gram sample of hydrate, and after heating, 0.0712 moles was found. So the question is, what is the formula and what's the name? So the first step will be is take the anhydrous amount and convert that to mass. So by looking at the periodic table, you can add up the amount of cobalt and 2 chlorines, and that gives you 129.84 grams of compound. So moles times the molar mass gives you the mass of cobalt chloride, and that's anhydrous chloride. So notice that we needed that mass because we wanted to figure out what is the difference between the original amount and the anhydrous amount, and that gives us 2.51 grams of water. Now we have to convert that mass to moles of water. So notice we have 0.139 moles of water that was removed from the hydrate. And then we need to look at the ratio. So we take the moles of water and we divide it by the anhydrous amount, and that gives us a ratio. So we've got 1.95 ratio of water to cobalt chloride. So when you write the formula, notice it's the anhydrous compound dot 2 waters. Okay, so in summary, the hydrate consists of an ionic compound and then a dot with the number of water molecules that's associated with that formula unit. Notice that each hydrate has a prefix. So if it's only 1 water, we're going to call it monohydrate. If it's 5, we're going to call it pentahydrate. And then lastly, anhydrous compounds are formed when hydrates are heated, and we can determine the amount by figuring out the mass of water that's released. And then we just look at the ratio of moles of water to moles of anhydrous compound.